We need to find the complete integral of this equation. For that, let's take our f to be the left hand side of this given equation. And then we need to find the details. What is the derivative of f with respect to x? It is minus 2p. Fy will be minus 2q, right? Fz, there is no z in this given equation, so it is 0. Fp, that is equal to twice of p minus twice of x, that is twice of p minus x. Similarly, what is Fq? It is twice of q minus y. Now we put all these details into the Charpit's equations, these ones. So dx divided by what is Fp? It is twice of p minus x, equal to dy divided by Fq. It is twice of q minus y. Dz divided by p multiplied with Fp. So it is twice of p into p minus x, plus q multiplied with Fq, that is twice of q into q minus y. These are your Fp and Fq, right? Very fine. Okay. Then dp divided by negative of fx. Fx is minus 2p, plus p multiplied with fz. Fz is 0. So that's it. It is plus 2p, equal to dq divided by negative of what is fy? It is minus 2q. And because fz is 0, there is no need to write. It is plus 2q. Now we need to choose those ratios from which we can get the value of p or q or the relation between these two, right? Let me choose these two ratios, the last two ratios, right? It is easier. 2 and 2 cancel from this. We have dp divided by p equal to dq divided by q. Very easy. Integrating both the sides, what we are getting? It is log of p equal to log of q plus the constant log of a, where log of a is a constant. So from here we get, so this is p is equal to aq by using the property of logarithm, and from here we are getting the relationship between p and q. How to get the values of p and q now? For that, let's use the given equation. Let's use the value of p as aq over here to get the value of q. When we put the value of p over here, we are getting everything in, means we are getting the value of q in terms of x, y. So when putting the value of p, we get a square q square plus q square. That will be q square into a plus 1. Sorry, that will be q square into a square plus 1 minus twice of, okay, this is a q x plus q y. So this will be, if I take q common, this will be a x plus y into q plus 1 equal to 0. So if you notice here, we are getting the quadratic equation in q, right? So what are the roots? The value of q will be minus b, that is twice of ax plus y, plus minus the square root of b square, that is 4 times ax plus y whole square minus 4ac. 4a is a square plus 1 and c is 1 here, divided by twice of a square plus 1. Please don't confuse with this a and the a I am saying according to the formula. Please match this with this. Okay, what is in the square root? Let's take 4 outside from the square root. So that will be 2, and 2 cancel from the numerator and the denominator. This 2 will be cancelled out from the numerator and the denominator. We have here the two values of q. but I'm going to take the positive one. That is, I'm using the value of q to be addition of the terms in the numerator. We must take the positive root of the quadratic equation, right? Okay. Now to get the complete integral, we need to use the equation dz equal to p dx plus q dy. So here what is p? We have p to be aq, dx plus q dy. Let's take q common from these, a dx plus dy. I'm taking q outside. How can I write this further? It is the derivative of ax plus y, isn't it? Into q, right? Here we have dz. So now we are going to put the value of q. So I'm writing here the value of q to be ax plus y plus the square root of ax plus y whole square plus ax plus y whole square minus 1 plus a square divided by 1 plus a square. This is the value for q into the derivative of ax plus y. Adjusting this 1 plus a square to the other side and now integrating both the sides. If I put ax plus y to be equal to t, I get the derivative of ax plus y to be equal to the derivative of t, right? So here for this integration, I have substituted ax plus y to be t plus the square root of t square minus, I'm writing here 1 plus a square, and for dAx plus y I'm writing dt. So we got this to be equal to, okay, integrating the left hand side we get this is constant, this will be 1 plus a square z. Integrating this with respect to t we get t square divided by 2, and integrating this with respect to t we get, there is a formula for that, that is plus t divided by 2 square root of t square minus 1 plus a square minus 1 plus a square divided by 2, it is cos hyperbolic t divided by square root of 1 plus a square. Please remember this, we have used the formula for this integral plus the constant b. Because I need this constant to be on the other side, so I'm writing here the constant to be as minus b, or you can also take that plus minus b, that becomes minus b. So taking this b to the other side we get 1 plus a square z plus b equals to, for t we have substituted ax plus y, so writing in place of t ax plus y everywhere to get the desired complete integral for the given equation. Minus 1 plus a square divided by 2, it is cos hyperbolic ax plus y divided by square root of 1 plus a square. So this is the required complete integral for the given differential equation. Alright, thank you.